I'm Anil Kumar, and in this video I'm going to derive the formula for surface area of frustum. Now students from grade 8 to 12 are actually interested in this particular formula. So my approach is to keep everybody's interest alive. So I will do approximation of trapezoid to get to this formula. Let's first talk about what is frustum, right? So frustum is when you have a cone and you cut off the top portion. Let's make one cone first. Okay, so if you have a cone like this and you cut off the top portion, let us say, then what remains is a frustum. So if I cut it off like this here, so what remains is this portion, let us say. That is what we call frustum. Okay, so this is frustum. So we have removed the top portion. So that portion is the frustum. Now this cutoff is parallel to the base. So these two sides are they are parallel. Okay, so these are parallel. So this forms a frustum. Now we need to find the surface area of the frustum. When we talk about surface area, there are two surfaces here to consider. One surface is the bottom part itself, and the other is the lateral area. This which opens which we call as lateral area. I should say three surfaces, the top part also, right? Now we will not get into details for top and bottom since you know those areas. Those areas are areas of circles, right? So what I will do here is just write radius of these guys. Let's say this is radius A, okay, and this is radius B. Okay. Now in that case, what I will say is that circles, right? So the top circle will be, let's say, area of top circle. Okay, I'm saving on space since I need a lot of space to derive the formula. Okay, area of top circle will be pi r square, which is b square, right? So pi b square, since b is my radius, and then area of bottom circle, right? So bottom circle is pi a square. Okay, so those are the areas of the circle. Now what we are really interested in finding the lateral area. Okay, to find lateral area, we'll need this slant length, right? So we say slant height. Let me say L. Okay, so that is the slant height. Actual height will be this part. This is the height of this frustum, but this is the slant height L. So we'll need the slant height L. So we'll say L is the slant height. So to derive the formula, I'll assume that we know radius of the bottom, radius of the top, and the slant height. So these things are given to us. Based on these things, we'll find a formula for lateral area. So the curved surface, I mean to say, right, the lateral area. You can also think like this, that if I cut it open, and let's say if I cut it open and just lay it on this table, then how will it look like? It will look like kind of like this. Kind of like this. Let's say this is, let me just sketch and then we'll talk about, let me just sketch bigger. Okay, so it kind of looks like this. So if I cut it open, right, this portion, and lay it on the table, now it becomes a two-dimensional thing, right? So these two circles, they correspond to these two circles, right? And this side is kind of the L, lateral area, right? Okay, so approximately it will look like this. So basically we need to find this surface area. That's what we are actually trying to figure out. I hope the situation is clear to you, what we are trying to do. Okay, Now, here is our approach. We'll use approximation of trapezoids to find the surface area. Now, trapezoids are very commonly used to find surface area of any curved surface. Even for people who are doing advanced calculus, they use this technique. So I'll show you how it works. So what I will do here is, to make it simple, let me divide it into 4 equal parts. So we have divided this into 4 equal parts. Now you can see that each part is like a trapezoid. If I join this and if I join this, right? So similarly we have this one also. I mean, my drawing is not all that good, but look from approximate things, right? So let's see like this, right? So what has really happened is I've made 4 trapezoids. That is my choice, just to make it clear. Now, what is area of trapezoid? What is area of trapezoid? Well, area of trapezoid, if I have this kind of a trapezoid, then because I used A and B here, I'll use some of the symbols here. So let's say X and Y. Okay, then area of one trapezoid, one we're talking about, will be half sum of these two, which is x plus y, times height, right? So what is height in this case? Height is this portion. That is the height. Okay, so that becomes the area of a trapezoid. Clearly, this height is the shortest distance between these two sides, and it is longer than our slant height. So in this diagram, this L is our slant height. Is that okay? Slant height is always greater than height. Perfect. But look here. What happens if I have many of these trapezoids, small ones, right? So if I make many trapezoids inside, in that case my height will approach L. Instead of 4, if I have 40, imagine that. So I'll have very small trapezoids. Let me make one here, clear, like kind of like this, right? So like this, right? Do you see that small one? Now in this case, my height will be very close to the slant height. Do you see that? That's the whole idea. So then if I say that there are many trapezoids, then what happens, right? So then what happens is we get a continuous band and we get the area of what we need. You get the point, right? So that is the approach for finding the formula, correct? So let's get back to this once again. So what we are talking about here is, we are saying area of trapezoid. Okay, so that is, in our case, since we took x and y, so we say it is half times the sum of opposite sides. That's a standard formula. We are not deriving that here. We can look into the videos where we have derived it already, times height. That is it. Now we say that, now these are 4, so if I want to find area of 4, I'll multiply this by 4. But how about, let me call this as A, okay. How about we have n trapezoids? Right? N trapezoids, here we have 4. If I have n, I'll have to multiply this area with n times. Is that okay? Half times n times x plus y times height. Does it make sense? Okay. Now, if my number of trapezoids increase, as you've seen here, as it increases, what happens? As n increases, let's say very large, we are saying infinity is a very, very large number. In that case, the height of the trapezoid becomes closer and closer to our slant height, which is L. Is that okay? So if it increases, what really happens is that these trapezoids are very, very close and they cover the whole space. Do you see that? So if I increase these numbers, let's say make it very, very small like this, then the height and the slant height will be same. Do you see that? And the whole surface will be covered. So we'll get the whole area. Do you see that? Approximate, but very, very close. That's the whole idea. More the number of trapezoids, closer it is to the surface area of the frustum. So if we do that, then we get lateral surface area of frustum. Do you get the idea? Is that okay? So let me call this as S, where n is very, very large. In that case, my height will be L, right? So I have half of, if n is very, very large, in that case, let me take this n inside. So we have n times x plus n times y, and this height becomes L, right? This height becomes L. Now what is n times x? N times x is the small bits, correct? Along the inner side. So n times x is inner circle, correct? So let's look into it in a bigger view, right? Let me just again make it once here. So we are having kind of like this, right? And we are having outer circle, let's say kind of like this. Now, if I have these trapezoids, okay, kind of continue like this, and if each is x units, right, the small ones, then n of these means nx, but it is what? It is the circle which we open. It is the whole circle which we open. Do you understand? It is this small whole circle which we open, which is on the lower side. Is that okay? So this lower side represents the top circle. It represents the top smaller circle, right? Whose circumference is 2 pi r, right? Which is 2 pi b. Do you see that? And this bigger one is the top circle, is the bottom circle, the bigger one, right? So this is 2 pi a, this side. Do you understand? So that is how they are. And n times x is actually the inner or smaller circle. So we should write this as half of. So nx is, x is the inner side, so the smaller circle. We can write this as 2 pi b. And the outer circle is this circle, which is 2 pi a times L. This does make sense to you, right? And now we can cancel these 2's. So we say, or multiply by half. So we get pi b plus pi a times L, right? Or taking pi common, so we get pi, I could write this a plus b or b plus a, one and the same thing. L. Do you see that? Where a is radius of one, maybe top or bottom, you could change it always, right? So as we took a as the radius of the base and b as the radius of the top portion. So it is pi a plus b L. Does it make sense to you? So that is the formula for surface area of a frustum, right? So now let me write down the formula big and bold. And then we are going to use this formula to solve some questions, right? So we have surface area, this is lateral, as equals to pi a plus b times L, where a and b are radius, where a and b are radii of top and bottom, right? Is that okay? And L is slant height. So that becomes the formula which you can always use, correct? So that is the formula which you can use to solve questions. Now let me give you a question here. So let's have a frustum now, okay? And let us say, it's a question which we already did. but we derived kind of most of the formula to do it. Now see how simple it becomes when we use the formula, right? Of course it will be, right? Let us say this portion is, radius is 12, this is 20, and this time we are given the height. In that case, find the surface area. So find surface area of the frustum whose radius on the top is 12 and the bottom is 20. How will you do it? Now, it's not that simple. It's kind of tricky. So what we can do here is we can cut it across and see at this figure. So we have a trapezoid here. This area, right? This is what L is, correct? And what we are saying is that we are given the height h. So let me just make two more lines here so that we could write exactly what we have out there. We are saying this radius is 20. That means this is 20. Is it okay? And we are saying that this portion is 12. Then if I extend this, or I can do like this also, doesn't matter, same thing, right? So we are saying this is 20, we are saying this is 20, right? Okay, and we are saying this is 12. Then can we find L? Knowing height. So we say let height be equals to 15. Okay, so we'll take height as 15. Okay. So in this case, we are given that A equals to, A is the smaller one, let's say 12, B is equals to 20, and height is equals to 15, and we need to find surface area, lateral surface area. Then to use this formula, you need to find what L is, not height, which you could calculate knowing this. So if this is 20 and that is 12, what is that? 20 minus 12, correct? So what we can do here is we can find what this, look at this triangle, right? So in this triangle, 20 minus 12 is 8 and this is 15. So we can find L. So L is equals to square root of 15 square plus 8 square. Does it make sense to you? Right? So that is square root of 15 square plus 8 square, which is equal to 17. Okay, so L is 17 for us. Now if L is 17, I can use this formula now, and I say it is pi times A plus B, which is 12 plus 20 times 17. Does it make sense to you, right? So let me just mark this portion off. Okay, and we can just calculate this value. Let's do that. So pi is 3.14 times 17 times, within brackets, 12 plus 20, bracket close, equal to, in decimals, we get this value as equals to 1708.16, correct? So I hope you learn in this video how to derive the formula and how to apply it. So we derived the basic formula for surface area of frustum by opening up, making it a two-dimensional figure, and then marking out few trapezoids. If we increase the number of trapezoids, then the surface area of combined trapezoids is same as the surface area of the frustum. And if n is very large, height of the trapezoid is very, very close to the slant height of the frustum. So we're taking advantage of that. We derived a very simple formula, which is pi a plus b L. Now you can also sometimes rearrange it by adding and dividing by 2. So if I do that, we get 2 pi, and a plus b divided by 2 will be average of these two. So you can also say it is 2 pi L, where 2 pi RL, where R is average of these two, right? So at times we do use that formula also. Anyway, keep it on the side for the time being. And here we took an example where we were given radii of top and bottom and the height. Now we were not given the slant height L, which we calculated using Pythagorean theorem, that is what, and so, and some tricks, right? So difference between 20 and 12 gives us this length, right? The base of the right triangle, height is known, hypotenuse was 17. Using 17 as L in our formula, we found the surface area. I hope all these strategies help you to solve questions based on Frustum. I'm Anil Kumar. You can always share and subscribe my videos and keep posting questions as you have been doing. Thanks a lot for your cooperation and time. Thank you.